Pleased to have Tom Preet, Vice President of Engineering at Pratt and Whitney, at the table. You're a UConn grad,
I am.
Which I love. I thought after working in television news so long in this state that it's about time we had some kind of a primer on Pratt and Whitney.
Great.
And the buildup over the years since the 1920s about what you've given to aeronautics. So let's kind of start at the beginning. How'd you get to Pratt and Whitney?
Well, Pratt and Whitney, I joined Pratt and Whitney soon after I graduated college at UConn, and
Your mom was happy you were employed.
I was happy employed. I was able to pay the bills that I had built up, and UConn, Pratt and Whitney represented a company where, you know, I always loved aviation. We can talk about that a little bit.
Let's talk about it right now.
Okay,
Why'd you
great.
love aviation?
So aviation's kind of, it sounds like a little Hollywoodish, but you know, I grew up in the Air Force. My father was a pilot in the Air Force, and literally since the time I was born, I remember smelling jet fuel at being near the base, and then being around aircraft, hearing the noise. We moved quite a bit together as a family. I'm one of 4 kids. But I remember moving from base to base as the Air Force needed, and I was born in Oklahoma. We moved to Ohio. But all that time, the constant was sort of being around aircraft, and remembering times when going to the air shows with my father and my mother and the family, and just knowing somehow that someday that would be what I would do my career in.
And so that was 1988, you came aboard. Pratt Whitney employs thousands and thousands of people over the years. This started in 1925.
Yes.
We have some pictures here, and I just kind of want to, I love the vintage pictures and how a company gets built. So let's start with this one and just explain what this is, because most of us would not know.
Well, this is what you see in there is a very early test stand. Pratt and Whitney tests, builds, and designs engines, and that's a very early shot of a Wasp, and we'll talk about that. But that's a Wasp.
What is a Wasp?
Wasp is essentially the first engine design that was done in 1925. The story is Frederick Rentschler, who was the founder of Pratt and Whitney, and you guys know it as UConn's home field, started a company in 1925, and he had been an engineer and a leader at a competitor, and he came up with the idea of what's called a water-cooled engine. At the conventional wisdom of the time, the conventional wisdom of the time was that a water-cooled engine was the right design, and he had the idea of changing to an air-cooled engine. And what that allowed to do is to increase the thrust or the power to weight ratio significantly. He brought that idea to the competitor at the time, the people he was working with, and they soundly rejected his idea. And that afternoon he left the company and started what we know now as Pratt and Whitney. So he brought 3 of his buddies from the Wright company, was where he came from, and he designed the Wasp engine.
And that led to, let's look at the next picture. How far from that engine did we get to the assembly line here? Well, is this still the 1920s?
Yeah, this is 1920. So he started the company, it started essentially in August or July 14th of 1925. He started the company, and by Christmas Eve that same year, he had designed, manufactured, and actually was testing the very first engine. And you see the picture of an engine right there, similar to the one he tested very, very early on.
And let's go to the next picture.
So what happened then is the Wasp was widely accepted by the aviation.
Was that 425 horsepower? Is that what
roughly,
I was reading?
425 horsepower.
I have no idea what that's like. Can you, to the layperson, tell me what that means? I mean, a lawnmower or something.
Yeah,
okay.
that would be equivalent to probably one of a performance car today, like a car that would be a high performance sports car would be somewhere around 400 to 500 horsepower, 550 horsepower. So, for its time, it was pretty advanced. And like I said, its big advantage was it was lightweight compared to other engines of its time. And given it didn't have the water systems to cool it, it was air cooled. It had a lot higher reliability, and this resonated with the aircraft manufacturers of the time. So then as you know, World War II broke out, and by the time World War II ended, Pratt and Whitney had supplied almost all the fighter power for the U.S. Navy at the time, and so Pratt and Whitney is very proud of the fact that it powered a lot of the war fighters in World War II to win the war and win our freedom as we know it today.
Next picture. These are some of the founders that we're looking at.
Those are the founders. So it's Frederick Rentschler, George Meade, Hobbs, and Wilgoose. These are the beginning founders of Pratt and Whitney. There was an engineer, manufacturing engineer, a test engineer, and then an analytical engineer. And these are the folks that actually they actually founded what we now know as Pratt and Whitney in 1925.
Turned out to be a pretty good combination.
Pretty good combination of great teamwork.
Next picture. We know this plant, that's in East Hartford.
That's in East Hartford, and this is the funny picture because that front picture of the building is still, those two buildings are still there. In fact, that whole building is still there, and my office as the main admin is actually in the front building there.
And then to the back, we see Rentschler Field, which
Right.
of course is UConn's.
It looks like farmland back there, but now that's became Rentschler Field, and then of course UConn is back there where we play our football games now.
Next picture. I
One of my
was
favorites.
fascinated. That is Amelia Earhart.
That's Amelia Earhart.
Is that a Wasp engine in that plane?
It absolutely is. So one of the little facts that people may not know is that the power that she used during her famous flight was actually a Pratt and Whitney engine.
That's amazing. Next picture.
Again, these are an iconic Wasp. These are the more advanced, higher horsepower. Those look like they're probably more like 1,000 shaft horsepower. And so that's an advancement, and those are more advanced engines that as you got into the 30s and 40s, just before the jet age came, those would be the twin Wasps.
Pratt & Whitney's competition is GE and also Rolls-Royce.
Correct.
How do you set yourselves apart?
Well, I think the way you set yourself apart is by creating innovative products. And one of the things that we're very proud of now is we have what's called the GTF, or it's a geared turbofan, which is a remarkable step change in performance from previous engines. This is an engine that we're designing and developing and certifying right now. In fact, the picture that you have showing the first flight of the A320.
Let's put that up if we can. This is the last picture, and I want you to explain this Airbus. I just came back from Europe on an Airbus. These planes are enormous.
Right.
I don't even know how they get off the ground. Tell me how this one got off the ground, and you were at the first flight.
So as I mentioned, this is a brand new family of engines called the geared turbofan, and typically when you go from engine variation to engine variation, you measure improvements in fuel efficiency on the order of 1 or 2%. We had been working on a technology called the gear system, or geared turbofan system, which essentially allows the fan to turn at a lower speed than the turbine. Conventional wisdom said you had to trade off and they had to run at the same speed. This allows the fan to run at an optimum speed and the turbine to run at an optimum speed. And the results staggering. I mean, this engine on this aircraft is roughly 15 to 16% more efficient than any other engine.
Can we drop the prices then on commercial airliners?
Well, there's a significant fuel savings. I mean, if you look at the amount of fuel savings that an engine like this will generate with a large fleet, it's on the order of $15 billion of fuel savings over 10 years. So it's a significant amount of fuel savings. And the other thing that comes with that is you reduce the fuel consumption, emissions in carbon dioxide is dropped significantly. So the emissions, the regulated emissions drop in half compared to the conventional engines that are in the field right now, and the CO2 emissions drop significantly as well. So it's a good thing for the environment. It's a good thing from a green point of view as well.
From your standpoint, you've traveled a lot with Pratt and Whitney. How much input, what was your part in that engine that went on the new Airbus?
Well, this has been something we've been working on 10 years, and what you see is
just 10 years. It seems like it would be
it's a
longer
long
than that.
time, but there's a lot of money and technology that goes into this. Now, this what you're looking at, there's a culmination that happened. I was lucky enough last week to be in France, and this is the first flight of the A320 with the new engine and the geared turbofan. It's the PW1100. And to watch that engine take off, the aircraft take off the ground right in front of me, it was such a gratifying feeling knowing that you had so much to do with that and your team had so much to do with it. To see it lift off the ground, it was truly an amazing feeling of gratification. And then the other thing is what becomes very obvious is the noise reduction of the aircraft is significant because this fan turns at a much lower speed.
Is it quieter for the people on board the plane then?
It'll be much quieter for the people on board the plane, and in terms of the people living around the airport. For example, there's 500,000 people that live around LaGuardia Airport in New York. They'll see a marked reduction in the amount of noise that they hear from the airport as a result of this technology.
We've talked about a lot of milestones with Pratt & Whitney. One thing that you did do along the way when you were developing engines is you put them in Formula One cars. How did that come about? How did that go into race cars?
Well, what it was the folks that were working on that some of the race cars were looking for a step increase in power output. So they asked us to put a turbojet on the back of one, and to say the least, it went very, very fast.
And you're not doing that anymore.
Well, we don't do that anymore. Our main focus is on aerospace propulsion.
Tell me about, you power more than 25% of the world's passenger aircraft.
Yep.
That's a very nice fact. Your engines have more than 1 billion flight hours of service. How many men and women since 1925 have gone into this? How many tens of thousands?
Wow, that's a tough.
Tens of thousands, I guess
Tens
we
of
should
thousands.
say.
And the beautiful thing about at least this story, especially in the geared turbofan, is this is all Connecticut designed. The engineers that designed this aircraft, and in fact that have made our history that we've talked about, are Connecticut people, right? Connecticut engineers from Yukon, places like Yukon, that decided to go work for a company like Pratt and Whitney and make a mark. We have a saying at Pratt that I really much like, is because we have a long history, of a long legacy, and such a remarkable history, innovation is part of our DNA. We like to say we like to leave the company like in a place where our children can work. In other words, leave a legacy that if our children decide to work at Pratt and Whitney, we leave it at a better place than when we got it. And that's something that drives all of us every day.
A lot of innovation going on at Pratt and Whitney as well. What could be next without giving away secrets? You've got the Airbus off the ground. You've got this engine. I mean, the sky's the limit,
Sky's
I
the limit.
suppose. Any work in drones? I mean, down the road, do you ever talk about drones?
Well, we actually power some of the large drones that you may have seen in an aviation week. There's something called the NUCAS, which is a unmanned vehicle for the U.S. Navy that's completely powered by Pratt and Whitney. People don't know that in Connecticut. On the military side, the Joint Strike Fighter, which is a replacement for the sort of F-15, F-16, and F-18 fighter jets. People don't know is 100% powered by the F-135, which is designed and manufactured, a lot of it in Connecticut. That's just getting off the ground. So if you think about, take a step back and say, look at Pratt and Whitney's future. Between the geared turbofan and the next generation product family and the F-135, we've got over 5,000 orders of a backlog of engine orders for the next 10 years. So our future's never been brighter, and it's really been off technology and innovation of the engineers and technologists that work at Pratt and Whitney. So it's a very, very exciting time to be at Pratt because our future is so bright.
And are there any secrets you can kind of tell us about marks in history that maybe people don't know about? The Amelia Earhart thing I had no idea about. Are there other little moments that you sit back and go, wow, Pratt and Whitney did that?
We probably talk hours about them.
Well, you got a little time,
okay.
So go ahead, Tom.
Let's talk about them. So look, I mean, one of the things that people don't realize is when you look at modern jet aviation, there's been two major steps. One was when we went to what's called a turbofan, and that was the 707 engine. It's the JT3, and it was designed in the 1950s. It really launched what we now know as modern commercial aviation. So 707s, you may remember, have long since gone, but in the 1950s and 60s, they were what moved people along. And then in the 1970s and early, the 747 came about, and it was really enabled by the JT9, which is the first large fan engine. And you probably see, when you go into the airport, you see big fanned engines on big aircraft. The JT9 was really the first high bypass engine. So those are two major pieces of history, and that JT9 really launched the wide-body aircraft that we know today. And this next big step with the geared turbofan system is really the next evolution of that. So it's the next big improvement in aerospace propulsion. But on the military side, equally amounts of milestones. For example, the SR-71, you may know in the 1960s, was a spy plane. It was used to spy and use reconnaissance for the U.S. Air Force and the U.S. government. It flew on the fringes of space, and it was powered by a very innovative aircraft engine called the J-58. The J-58 was designed in the 1960s with slide rules, no computers, and no computer graphics and computer programs, but by very innovative engineers that figured out how to do something that the government said, we need to fly close to space. How could Pratt and Whitney provide an engine? And we did. And then, like, one of the most exciting times I've seen is I got the sort of benefit of being and the privilege of being on the F-22 engine, which is the F-119. And the F-122 is the Raptor. It's an air superiority aircraft. It's an amazing aircraft. In the early 2000 timeframe, I saw the F-119 power the F-22 in amazing first flights, seeing it essentially go down the runway, pull vertical, and accelerate supersonic straight up in the air. it's just an amazing thing to see, especially if you love it and have a passion for aviation. Seeing these things gives you goosebumps. And in fact, you come to work every day and you kind of say, what are we going to do today for fun, right? What problems are we going to solve, and what new and exciting things can we do for our customers?
And I'm thinking and hoping there's a lot of bright minds coming out of UConn, out of their engineering department, to go work at Pratt and Whitney.
Well, we certainly hope so too. And in fact, we're investing in that. We have what's called a Center of Excellence that we've agreed with UConn about 5 years ago, where we invest in UConn. We invest in their school, we invest in technology that they generate, but we also invest in their students. We are very vested in them being able to create engineers, high quality engineers that we then can either hire if they choose to come work at Pratt and Whitney. And that's worked very, very well. And in fact, the majority of the students that we get per year come from UConn, and we're very, very proud of that fact. And our relationship for UConn is something that we want to continue to work on and have for a very, very long time. Besides, we love their football team and their basketball team.
Tom Preet, I appreciate so much that you came on and gave us a primer, if you will, about Pratt and Whitney. And if folks didn't know, they know now about what's going on there. Thanks again. I appreciate
Thank you so much. I really appreciate it.
You're welcome.
Pursuit, spend one this in. Who is this girl? Spend all night kissing, and if one was right here, then who else is missing? Got a little sidetracked to find myself wishing to find the keys to the door, but it's also a metaphor. Things to keep locked in the grocery store, but mine just to save time. Skip right ahead to the last ride. The harder we look, the less we can see. Don't you know that you